convertible main lug is a type of electrical panel providing the option to install either a main circuit breaker or a main lug. When a main lug is installed, the feeder wires connect directly to the lug, bypassing a circuit breaker. This configuration can accommodate a higher ampacity rating than achievable with a circuit breaker alone. NEC Section 240.21 addresses feeder tap rules and overcurrent protection. Specifically, NEC Section 240.21 states that when the ampacity of the feeder conductors exceeds the ampacity of the individual main circuit breaker or fusible switch, an additional circuit breaker or fusible switch shall be installed in the panel board to protect the feeder conductors. Let's analyze a scenario where a 200 amps main circuit breaker is located in an outdoor panel with a load center situated 35 feet from the house on a pedestal. Inside the house, there is a 200 amps convertible main lug. The feeder cable running from the main disconnect to the main lug consists of underground service entrance, or used 2/0 cable within a conduit. The key question is whether an additional, smaller breaker is necessary at the main lug given the feeder wires ampacity and if NEC Section 240.21 applies. The feeder wires from the main disconnect to the main lug have an ampacity suitable for the installation. Since the main lug is rated for 200 amps, installing an additional circuit breaker at the main lug isn't required. NEC Section 240.21 doesn't apply in this instance because the feeder conductor's ampacity does not exceed the main lug's ampacity. To reiterate, based on the information given, installing an additional breaker in the main lug isn't necessary. The 200 amps feeder wires can be connected directly to the 200 amps main lug without violating NEC Section 240.21. It's crucial to always consult the latest edition of the National Electrical Code and local amendments, as interpretations and requirements can vary. Furthermore, consulting with a qualified electrician is always recommended for specific installations and to ensure compliance with all applicable codes and regulations. To further elaborate on NEC Section 240.21, it is important to look at all aspects. Firstly, understanding the purpose of overcurrent protection is paramount. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical conductors from overheating and potential damage due to excessive current flow. This protection is crucial for preventing fires and ensuring the safety of electrical systems. Secondly, NEC Section 240.21 is specifically concerned with tap conductors. A tap conductor is a conductor that is connected to a feeder conductor at a point between the overcurrent protection device and the load. The tap rule allows for a reduction in the size of the tap conductor compared to the feeder conductor, provided certain conditions are met. These conditions are designed to ensure that the tap conductor is adequately protected from overcurrent. Thirdly, the ampacity of conductors plays a vital role in determining the appropriate overcurrent protection. Ampacity refers to the current carrying capacity of a conductor, which is the maximum amount of current that the conductor can safely carry without exceeding its temperature rating. The ampacity of a conductor is determined by factors such as its size, material, insulation type, and installation conditions. When the ampacity of the feeder conductors exceeds the ampacity of the main overcurrent protection device, NEC Section 240.21 requires an additional overcurrent protection device to be installed to protect the feeder conductors. This is because the main overcurrent protection device may not provide adequate protection for the feeder conductors in the event of an overcurrent condition. In the given scenario, the feeder wires have an ampacity suitable for the installation. Since the main lug is rated for 200 amps, there is no need to install an additional circuit breaker at the main lug. NEC Section 240.21 does not apply in this instance because the feeder conductor's ampacity does not exceed the main lug's ampacity. However, if the feeder conductor's ampacity had exceeded the main lug's ampacity, then NEC Section 240.21 would have required an additional overcurrent protection device to be installed to protect the feeder conductors. It is important to note that NEC Section 240.21 is just one part of a larger set of rules and regulations governing the installation of electrical systems. It is essential to consult the latest edition of the National Electrical Code and local amendments, as interpretations and requirements can vary. Furthermore, consulting with a qualified electrician is always recommended for specific installations and to ensure compliance with all applicable codes and regulations. Let's consider some examples to illustrate the application of NEC Section 240.21. Example 1. A feeder conductor has an ampacity of 300 amps and is protected by a 200 amp circuit breaker. A tap conductor is connected to the feeder conductor and supplies a load. In this case, NEC Section 240.21 requires an additional overcurrent protection device to be installed to protect the feeder conductor. The additional overcurrent protection device must have an ampacity no greater than the ampacity of the feeder conductor, which is 300 amps. Example 2. A feeder conductor has an ampacity of 200 amps and is protected by a 200 amp circuit breaker. A tap conductor is connected to the feeder conductor and supplies a load. In this case, NEC Section 240.21 does not require an additional overcurrent protection device to be installed to protect the feeder conductor. This is because the feeder conductor is already protected by a 200 amp circuit breaker, which has an ampacity equal to the ampacity of the feeder conductor. Example 3. A feeder conductor has an ampacity of 100 amps and is protected by a 100 amp circuit breaker. A tap conductor is connected to the feeder conductor and supplies a load. In this case, NEC Section 240.21 does not require an additional overcurrent protection device to be installed to protect the feeder conductor. This is because the feeder conductor is already protected by a 100 amp circuit breaker, which has an ampacity equal to the ampacity of the feeder conductor. It is important to note that these are just examples, and the specific requirements of NEC Section 240.21 may vary depending on the specific installation. Always consult the latest edition of the National Electrical Code and local amendments, as interpretations and requirements can vary. Furthermore, consulting with a qualified electrician is always recommended for specific installations and to ensure compliance with all applicable codes and regulations. In addition to NEC Section 240.21, there are other relevant NEC sections that may apply to the scenario. One such section is NEC Section 310.15, which covers the ampacity of conductors. NEC Section 310.15 provides tables and guidelines for determining the ampacity of conductors based on factors such as their size, material, insulation type, and installation conditions. Another relevant section is NEC Section 250, which covers grounding and bonding. Grounding and bonding are essential for ensuring the safety of electrical systems and for preventing electrical shock hazards. NEC Section 250 provides detailed requirements for grounding and bonding electrical equipment and systems. It is important to consider all relevant NEC sections when designing and installing electrical systems to ensure compliance with all applicable codes and regulations. Furthermore, consulting with a qualified electrician is always recommended for specific installations and to ensure compliance with all applicable codes and regulations. The type of conductors used, such as use cable, also plays a role in determining the appropriate installation methods and protection requirements. Use cable is specifically designed for underground service entrance applications and has a moisture-resistant insulation. However, it is still important to protect use cable from physical damage and to ensure that it is properly installed in accordance with the NEC. In the given scenario, the use 2/0 cable is installed in a conduit which provides additional protection from physical damage. The conduit also helps to prevent the cable from being exposed to direct sunlight, which can degrade the insulation over time. When selecting conductors for an electrical installation, it is important to consider the environmental conditions to which the conductors will be exposed. Factors such as temperature, moisture, and sunlight can all affect the performance and lifespan of conductors. It is also important to select conductors that are specifically listed and labeled for the intended application. This ensures that the conductors meet the appropriate safety standards and performance requirements. In addition to the conductor type and installation methods, the overcurrent protection devices used in an electrical system must also be properly selected and installed. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical conductors from overheating and potential damage due to excessive current flow. The overcurrent protection devices must be sized appropriately for the conductors that they are protecting. This means that the overcurrent protection devices must have an ampacity that is no greater than the ampacity of the conductors. It is also important to select overcurrent protection devices that are specifically listed and labeled for the intended application. This ensures that the overcurrent protection devices meet the appropriate safety standards and performance requirements. Proper selection and installation of overcurrent protection devices is crucial for ensuring the safety and reliability of electrical systems. When working with electrical systems, it is always important to follow safe work practices. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and energizing circuits before working on them. It is also important to use properly insulated tools and equipment and to avoid working in wet or damp conditions. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. If you are not qualified to perform electrical work, it is best to hire a qualified electrician to do the work for you. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with all applicable codes and regulations. Improperly installed electrical systems can be a fire hazard and can also pose a risk of electrical shock. It is important to ensure that all electrical work is performed by a qualified electrician to protect yourself and others from these hazards. In conclusion, when dealing with electrical installations, understanding the National Electrical Code, particularly sections like 240.21, is crucial. This section focuses on overcurrent protection for tap conductors, ensuring safety and preventing damage from excessive current. Determining whether an additional circuit breaker is needed in scenarios like the one described depends on the ampacity of the feeder conductors and the rating of the main lug. The type of conductors used, installation methods, and environmental conditions also play a significant role in ensuring a safe and compliant electrical system. Always consult the latest NEC edition and seek guidance from a qualified electrician for specific installations. Prioritizing safety and adherence to regulations is paramount in all electrical work.